Hi friends, welcome back to the series of creating cluster using Red Hat 7 operating system, and this video is part 2 of the series. In our previous video we have seen how we can prepare Red Hat nodes, install our Red Hat operating system, and then configure it for hosting my iSCSI target, creating my yum server, and making my cluster nodes talking to this particular yum server for pulling all the packages, and configuring my yum server as a unit for holding the targets. We are using a demonstration in this by using the RHEL 7 target CLI for preparing our cluster storage devices. So by using target CLI, we have generated our iSCSI targets, and here I have my two cluster nodes, cluster node 2 and cluster node 1. Both of them are connected to my iSCSI. Both of them are using my iSCSI initiator protocol for pulling up the targets from my remote location. And here we can validate by running our ls blk command that here I am having three devices: disk 1 on which I am having my operating system, and my SDB, SDC and SDD coming from my iSCSI targets. So let's see, iSCSI ADM -m session, and sure. So it shows that I am having a session established with my iSCSI targets. The same, let's validate if in case the same session is established here also. iSCSI ADM -m sessions. So it gives me the details of my session there. Okay. So we have our two sessions. Both the nodes are connected to my yum server. So now whatever job we have to do is we need to perform these operations on my client side. So for making my cluster configuration, we all know that my clusters communicate over multiple or multicast channels. The internal cluster communication, the internal heartbeat of your clusters is maintained over your multicasting channels there. Okay. So the entire cluster communication, as we all know that in case of clusters, the communication or the cluster keep alive requests, they happen over my multicast environments. So first thing is we need to ensure that all my cluster nodes are able to talk to each other with a host name resolution. That is, they are able to talk to each other using their names as well as their IP addresses, because the cluster requires me to have a name-based resolution services. So for this purpose, either you should have a proper DNS server configured in your network. If in case you do not have a DNS, then the turnaround, or we can have a walk around for that problem is we can use etc/host file for our name resolution. So let's validate if in case I have my etc host file. Yes, my etc host file on both my cluster nodes is the same. Okay, and from both my cluster nodes, from my cluster node 2, I can talk to my cluster node 1 by using its name. I have a name-based communication active. The same thing from my cluster node 1 also, I can talk to my cluster node 2 using name-based resolution. Okay, that's good. Next thing that we have to do is we need to test our multicast communication. So how we can test our multicast communication? For this purpose, in Red Hat environments or in your CentOS 7 environments, there is a utility available, there is a package available called as my omping package. So what I can do is yum -y install omping. Install this package on both your cluster nodes. Yum -y install OMT. Once this package is installed on both of your cluster nodes, then validate your multicast communication by providing the name of both of your cluster nodes. So omping cnode1.demo.local. Run this command from your cluster node 1 and wait for packets to join from your cluster node 2. omping cluster node 1 dot demo dot local followed by cluster node 2 dot demo dot local. Go back to your first. Here also run the command followed by the name of both of your cluster nodes. So if you are getting this message, joined group 232. So if you recall, all the IP addresses above 224 are my multicast addresses. So if I am getting this pinging reply, I am getting this communication from my cluster node 2 on C node 1 and on my cluster node 1 from my cluster node 2. So once you get this communication tested, now we can say that both my cluster nodes can have a heartbeat enabled between them. So when my cluster service is going to work, the cluster service will be having a valid heartbeat channel available to it. Both of them can communicate over my multicast networks here. So we have both our cluster nodes ready for hosting my multicast communication. Okay. Now next step is I need to install my PCS daemons and the PCS agents on my system. Okay. So for this purpose, on both my cluster nodes, I need to install my PCS, the pacemaker software, fence, agents, all, my HTTPD service for getting my HTTPD communication. I'll be hosting a Apache based PCS cluster based Apache web server, which will be letting me to have cluster node hosted on here. Okay, my highly available cluster with Apache agents. Oops, it says that. Oh, my mistake. I haven't gained the install command here. This might take a lot of dependencies. Just repeat the same command on your second cluster node also. yum-y install pacemaker software, fence, agents, all, HTTPD and wget. Okay, so just wait till both these packages are getting installed on your system. So like friends, if you recall, in our older days, we need to set a password for our RHEL agent on all the clusters in Conga cluster or Red Hat 6 clusters environment. In case of my pacemaker environment, we need to set a password for an agent called as my HA cluster agent. For authenticating all my cluster nodes in a pacemaker cluster, on all the cluster nodes you should set a password for HA cluster. HA cluster is an inbuilt user. Grep HA cluster from hc/passwd. The moment you installed the PCS software, this user got created for you automatically. So my suggestion is keep the same password on all your HA cluster agents. That is, prefer to have a same password on all your cluster nodes, because anyhow you are going to have your cluster in a demilitarized zone area, and it will be accessing to your web services coming through various network environments, or you can say through your corporate firewalls. Okay, so I'm keeping up my password here. Okay, the same process I'll have to repeat on my second cluster node also. Password ID HA cluster user. I'm keeping the same password here on both my nodes. It is done. Now rest of the steps, after starting my pcsd service, I can perform from any one of my cluster nodes. I need not to repeat the steps on all the nodes there. Just I have to start my pcs service, and after that all my cluster configuration can be completed from one single cluster node. Okay, so here what I'm doing is I'm just starting my pcsd service and marking it to be started automatically. systemctl enable pcsd and then start my pcsd daemon. pcsd is my pacemaker cluster service daemon. systemctl enable pcsd on my second node also, and then systemctl start pcsd on my second node also. So once I have started my pacemaker service, now I can select any one of my cluster nodes and can continue with my configuration from there. Okay, so now next step is I need to create a cluster and authenticate all my cluster nodes into my pacemaker daemon. So this authentication, how we can perform it? By running the command pcs from any one of your cluster nodes, pcs cluster authenticate your first cluster node name, followed by your second cluster node name, followed by third, fourth, fifth, up to the maximum number of nodes allowed in your pcs cluster. So it's asking me for username, which is HA cluster on all my cluster nodes, and the password, as we have kept the same password, what it says, unable to communicate with c.2.demo.local. Let's see. Okay, let's check the status. If it is started, it's active and running. System, okay. CTL. For the time being, I'll have to disable my firewall D service, because right now I have not configured my firewall properly. I have not configured my firewall rules, so I'll have to stop it. I'll have to flush my IP tables and set my enforcing to permissive. Let's do the same thing here also. Set enforce 0. systemctl stop firewall D and disable firewall D. Let's try to authenticate our cluster again. HA cluster authorized. Okay, so once both my cluster nodes are authorized into my pcsd cluster, now next step that I have to do is create a location or create a path that you will be using for your web cluster there. Okay, so here I'm doing what, mounting my var www.html directory on both my cluster nodes to the same path. So mount dev slash sdb. Wait, I'll have to firstly do mkfs dot right side xfs dev slash sdb. Done. And here I'll have to, I'm mounting it dev slash sdb on my web www html directory and creating a file web www html index.html here, and making only one entry in this file, that is h1 welcome to wake 3D HA cluster demo plus h1, closing it, saving it, coming out of it. Why I have done it? So that on all my cluster nodes I am getting the same path there. Okay, so here also I'll just do iSCSI ADM, will log out and log back in. Log out and log in again. Now let me check. Okay, here also I'll do the same thing, mount dev slash sdb on slash var www html directory. I should be able to get that index.html file on my second node. Yes, good, I am able to view it. Okay, I just unmount it because this is a thing that my cluster should be doing it. So I'm unmounting my var www html directory because it is my PCS daemon which is supposed to mount it there. Okay, so here also I'll unmount it, var www html directory. Now next thing is I have to create my cluster configuration. So PCS cluster setup hyphen start hyphen name. By what name you want to identify your cluster? I want to identify my cluster by the name web cluster, which is comprised on the basis of cnode1 dot demo dot local and cnode2 dot demo dot local. My cluster started, double thumbs up. Okay, and if you are also able to do the same thing, give a pat on your back, friends. Now next thing is I need to enable my cluster service to start automatically. Okay, PCS cluster enable hyphen all. My cluster is enabled on both the nodes. Now next thing is we need to configure a fencing agent for Stonith services. So there is a particular scenario. If in case we are talking about a 2-node cluster, and in those 2-node clusters, due to any reason, if my heartbeat fails, then both the cluster nodes will be thinking that the other cluster node is down. That is, the pcsd daemon will try to turn off the another cluster node, which is called as my split brain condition. Okay, so this is referred as my split brain condition. To avoid split brain condition on specifically Linux cluster servers, we have a terminology, we have a concept called as shoot the other node in the head, which is called as my Stonith. This is a specific scenario for 2-node cluster configured on Linux environments. So for this 2-node cluster configuration, I need to take care that it gets Stonith in case of a split brain scenario. So for this purpose, I am going to create a iSCSI based Stonith unit. PCS. So for that purpose, the command is PCS Stonith create iSCSI hyphen Stonith fence underscore SCSI, which will be done by devices, that is dev/sdc in my case. Okay, done. To validate if in case this Stonith device is configured, PCS Stonith show iSCSI hyphen Stonith hyphen device. Oops. Okay, I created it by the name iSCSI Stonith. It shows that there is a resource by the name iSCSI Stonith, class is Stonith, type is fence, SCSI, attributes, it is taken care by dev/sdc, and monitoring interval is 60 seconds. Okay, which if in case you want, you can modify it by changing the value of this iSCSI Stonith monitor interval. Okay, I got my iSCSI. Now next thing is I have to tell my SCSI unit, I have to tell my pacemaker cluster that it will be getting its var www.html location from my iSCSI based file system. So this we will be doing by creating a resource as PCS resource create file system. Okay, resource by the name file system resource, where it is file system device equals to dev/sdb. This is the device which we have taken for our things. Okay, where my fs type is equals to xfs, and it is identified by the group name as Apache group. Oh. The command will be my, okay, I have done one small mistake here, that is my group spelling is wrong. Hyphen group Apache group. Create resource, fs resource. Okay, that got created last time. I'll just give it a new name. Web fs resource. Okay. Okay, it's just a warning, nothing to worry about. It says that missing required options, directory for resource type. Yeah. Okay, let me do one thing. PCS resource delete, PCS resource delete fs, PCS resource show. There are no resources as of now. We'll create our resource here. Okay, so just I'll show you what exactly is the thing here. I'll just give you the whole command. Okay, it is PCS resource file system, where my device is dev/sdb, and my directory is, after this I have to mention here as where this particular resource will be accessible. So it will be referred on var www html location, and then my file system type is xfs, and it is being referred. Just give me a second, friends. Here, that is, I have not specified the create keyword. My resource got created here. Okay, now next thing is I need to create a resource that will be called as my virtual IP address. PCS resource create, let's call it as web IP, and the resource is of type IP addr2, that's my IP class, and IP is equals to whatever IP address you are publishing. I'm giving the IP as 192.168.1. Let me give it as 175. Okay, CIDR underscore netmask is equals to 24, and this again is going to be a part of my group Apache group. My resource got created. Now next thing is I have to create a HTTP resource. So PCS resource create HTTPD resource. This is my Apache config file, and this is equals to etc/httpd/con httpd.con. okay, and my status URL will be equals to http://127.0.0.1/server-status, and again it will be a part of my group Apache group. So we created 3 resources here. For this Apache health check status, we need to create a small http.conf file on both our servers. What we'll be doing is, in our httpd.conf, we will be just adding a small entry at the bottom. vi etc httpd conf httpd.conf file. In this file, just move to the bottom at the end of your configuration script and add some lines here, which will be my location entry, location/server status. This I'm going to set the handler as server hyphen status. My order will be deny and then allow, then deny from all the devices, all my machines, allow only from 127.0.0.1, and then close your location tag. Now I need to repeat the same process on my second node also. So I'll just do scp-r, my local file etc httpd/con httpd.con to my cluster node 2 demo dot local /etc httpd con. Yes, we provide the password and my file is gone. Let's validate if in case these changes have been updated here. Tail -8 etc httpd con httpd.con. Oops, what a time. Let's check. Yes, we got the entries here. So that means my file got replicated on both the terms. So now I may have Apache handler also on both the nodes. If in case you have your firewall active, we have to just check it if my firewall is allowing me to access it. Okay, open the HTTP service port on both on your firewalls. Now check your cluster status. Firstly, we will find out what all resources do I have. So PCS resource show. This shows me that I have 3 resources available: FS resource, web IP resource, and HTTPD resource. It shows me my heartbeat. Apache is stopped. What could be the fault here? Let me check. Just give me a second. So okay friends, my all the 3 resources are up. I have just not given the resource name properly. Now I need to check the status of my cluster on both my cluster nodes. So this I can view it by simply checking PCS status. So this should show me the status of my cluster. So here if I check, it shows me very clearly. Let me show it from the beginning. PCS status. Okay, so cluster name is web cluster, stack is Corosync, current it's C node 1, partition with the quorum, 2 nodes are configured, 4 resources configured, both the nodes are online. Full list of my resources: iSCSI Stonith resource started. Resource group is Apache group, which is having 3 resources in it: file system resource, web IP resource, and HTTPD resource. So currently it says that all these nodes, this group is started on my cluster node 1. So this means I should not get in my df-h output the var www html on my second disk. Okay, and let's check it on my first one also. df-h. So here I do not have that. So let's check if in case my website is accessible. So for this purpose, I'm just opening my web browser and trying to test if in case it's accessible there. I'll just set an IP address on my base machine similar to the IP what I have for my virtual machines there. Okay, I'll just validate if in case I can communicate with my web server IP. So ping 192.168.1.175 was the IP I have kept for my server. On my client it shows me it's not reachable. Okay, let me check what could be the fault here. My virtual machine is connected to host only. Let me make it to VMnet 0. Let me make this also on custom VMnet 0, and this one also on my custom, so it's not required anymore. Oh, it's required. It's giving me the host addresses. My pieces status, okay, it's up, online. So here I got a reply from my web server address. This was the address I have assigned for my IP resource. Now let's check if this site is accessible to me or not. So for this purpose, I've just opened my browser, http://192.168.1.175, and if I get my web page, that means yes, my HA cluster demo is up, and we have our Vivek Trivedi HA cluster class up there. Now let's try to migrate our resources from one cluster node to another cluster node. Okay, so as of now, if I check, it says that currently my resources are active with cluster node 1.demo.local, and resources are currently associated with which node? It's associated with my node 2. That is the reason if I check my IP address, here I have only one IP, 1.123, whereas when I'm going to my cluster node 2 and I check my IP address, it shows me that I have two IP address, 1.124 and 1.175, which is my cluster IP. It's my virtual IP here. So I'll just go one thing, I'll move my resource from that node to another resource. PCS resource move my HTTPT resource. If my command gets completed successfully, let's go and check back here. Earlier I'm having IP 175 here. Let's see if the same IP is again. The IP is gone on my node. Now where that IP is? That IP is here. Currently, if you see, I do not have that IP address here with me. Let's run the command again. That 175 IP moved to my cluster node. Let's go and check back. Earlier we have seen here that these resources are where? These resources are accessible from my second node. Now let's check the PCS status. Where my resources are now. All my resources have now moved to cluster node 1, which states that my cluster is working fine. And let's try to access our web page also again. Woohoo, my web page is not gone. And if I check it here, my reply is still coming continuously from my resources. Okay, let's do one thing. Let's place a ping-t and try to change the location of my cluster resource. Okay, I'm just doing one thing, keeping a continuous watch on my IP connectivity and testing my cluster resources, the movement PCS resource move web IP. I just had a delay of some milliseconds when my resource migration took. Just monitor it here. I was earlier having 1 millisecond ETL. Just it took 6 milliseconds to switch from one node to another node. My cluster is up, resource migration is happening, my site is up. Thank you friends for being with me and watching the video. Catch you soon in new videos related to my cluster, resources management and complete cluster solutions. Thank you. Thanks once again for watching my video.